Hey YouTube, in this video we're going to be discussing what we call the argument of a complex number in standard form. Okay, so we say the argument of a complex number z, which we usually refer to as some x plus yi, we say is the smallest positive angle theta from the positive real axis to the graph of z. Okay, and so what we want to do is we want to consider this graphically in the first place. I think I can draw on this here. Yes, but we say it is the smallest angle theta that starts on the positive x-axis, so we'd say that the initial side of the angle would be this part right here that goes to the graph of z. So let's say, for instance, we have some number here. We say z equals x plus yi, and there is some point xy over here. We say xy that is associated with this complex number here. So we say this is the number z, and z is x plus yi. But we could say, breaking this down, we say the argument is the smallest angle theta right here, that starts on the positive x-axis and goes to this number, z in the first place. So say, for instance, we had some number z here and it terminated over here. This is just, hypothetical, but we'd say that the argument of this complex number in standard form would be this angle theta here. And when we say the smallest angle theta starting over here and going to here, what we kind of mean is this. If you were to ever have a complex number that, say, was like right here, and this is where I graphed it, we'd say it's the smallest positive angle. So we would say it'd be not this angle right here, theta, but we say starting on the positive x-axis, the argument of this number would be this angle theta right here. And so when we say smallest positive, really what we're saying is that we're restricting theta here to be somewhere between and not including 360 degrees, but between that and 0. So the argument is what we're often after here. So I say let's consider the following arguments relating this number z equals x plus yi and the argument theta. But I would be willing to go so far as to say this, given any number x plus yi, we could say this could be our x plus yi here. We say this is some point xy that corresponds to this number x plus yi, which is some z. We say we could drop down in altitude, and we would say that we know this is y, we know this is x, and we know that this is some distance r here. But essentially the argument would be this thing right here. Now, the difference between this picture right here and this picture over here is that we had some x and y over here as well, and I could drop this down. I could say this is some y, and this is some x, and this is some r. But the idea here is this. If we wanted to find this argument, the way I'm going to share with you to do this is understand that if we know this complex number already, then we are already familiar with this x and this y. And if I knew two parts of this right triangle, with respect to this angle right here, the opposite side and the adjacent side, what we could say is then that the tangent of theta is always equal to y over x. That is, if we know y and x from this complex number, we could relate the angle to those two sides. Furthermore, what we want to say is this. We say the argument. We could say that theta hat is equal to the tangent inverse of y over x. So what this is going to do is allow us to kind of back solve for the argument here. So let's say hypothetically we've got a number here, and we'll call this number -3 plus 4i. And what I've been asked to do is go find the argument, which is the smallest positive angle starting at the positive x-axis out to this complex number. The first thing we want to do is we want to go graph this complex number. So we'd say, okay, well, -3 plus 4i would be left 3 and then up 4, 1, 2, 3, 4. So we'd have this complex number right here, and this would be our vector. Okay, so we'd say that this is the number -3 plus 4i, and if we were to make a triangle out of this, we could say that this is a positive 4 and this is a -3 and this is some distance r. The bottom line, though, is that we want to solve for this angle theta right here. We want to write this down because essentially what's going to happen every time is that we have this point here where we have -3 and 4. And since we know the complex number, we already know some x and y associated with its terminal side. So we could say that the reference angle, at least, we could solve for this if we knew the y and the x. So to find the argument, the first thing we do is find the reference angle. And we say in this case, we get tangent inverse of y over x, where our y value is 4 and our x value is -3. So we're going to get a calculator out now, and this is going to do the work for us essentially, but we say make sure that we're in degrees here, radians, degrees. But we'd say first things first, we're going to do tangent inverse of -4/3. We say 4 divided by 3, which is negative. We get this. We're going to do now the tangent inverse of this in degrees, and we get a -53 here. So we'd say our reference angle, our theta hat, is approximately -53-ish degrees. Okay. So what I'm going to do is I'm actually going to take this one extra place value, so -53.1-ish 0.1-ish. And we know that reference angles cannot be negative, so we say this is positive. So this is our reference angle. We know by drawing this that it terminated in the second quadrant. So what we just discovered here is this. We've discovered that this is a 53.1 degree angle as a reference angle. That's right here. So we say, what is this actual angle? We'd actually have to take 180 degrees minus this 53.1 degrees, and we get a new angle here. If I were to take 180 away from this as, shorthand, we make this positive again. Oops. Let's do it the long way. 180 minus 53.1 degrees. We get 126.9. So 126.9 is this here. We say this is some theta. Now we're going to give this a name. We refer to this as the argument of the complex number. Okay. So the argument of the complex number, let's be really clear on this one. We can always find the argument if we know this complex number already, because if we know an x and a y, we can go get the reference angle using this. So this is the formula we're going to memorize. Cheers.